Good morning to one and all present. So welcome to the 5-day FTP on recent trends in electric vehicle technology. Good morning, Srijit sir. We welcome you to the session, sir.
Very good morning, ma'am.
Good morning to one and all present. I request our HOD Dr. R.S. Krishna Naidu to welcome to the session, sir. Recent trends in
Amala ma'am?
Yes, ma'am.
Ma'am, actually, you need to close the YouTube tab in your system.
Yes, ma'am. It's closed. Thank you, ma'am.
Okay, ma'am.
Sir, please go ahead, sir. HOD, sir.
So please unmute yourself, sir. Naidu, sir.
Hello,
Yes, yes.
sir. Good morning, sir. Srijit, sir.
Yeah, very good
Yeah,
morning,
ma'am.
sir.
Yeah. Firstly, I would like to thank for accepting our invitation, sir. And ladies and gentlemen, a very good morning, and welcome to the second day of our faculty development program on recent trends in electrical vehicle technology. So today we have the privilege of welcoming a distinguished resource person, Dr. Srijit, sir, from NIT Silchar, who will be sharing his expertise and insights with us. So without further delay, I welcoming Dr. Surjit sir to share his valuable experience and insights with us to enhance our knowledge. So I request Mrs. Yamni ma'am, Assistant Professor in EEE Department, to read out the one-page profile of Dr. Surjit sir. Welcome, ma'am.
Thank you, sir. Very good morning to one and all. I'm Yamini, Assistant Professor in EEE Department. Let us all together welcome Dr. S. Srijit sir to the second day of our FTP. Dr. S. Srijit sir received BE in Electrical and Electronics Engineering from Nurul Islam College of Engineering, Tamil Nadu, 2003, and ME in Power Electronics and Drives from MEPCO Shillings Engineering College, Shivkasi, Tamil Nadu, 2005, and PhD degree from NIT Tiruchirappalli, 2013. Presently, he is working as Assistant Professor in Department of Electrical Engineering, NIT Silchar. Before joining NIT, he worked as Associate Professor in the Department of Energy and Power Electronics, School of Engineering, VIT Vellore. He is having more than 18 years of teaching and research experience. He has published more than 50 papers in referred international journals like IEEE, Elsevier, Springer, and international conferences. He is a reviewer in IEEE, IET, Elsevier, Taylor, and Francis, Springer, and lot of journals. He is serving as editorial board member in few journals. He has been granted an Indian patent and a German patent and published an Indian patent. He has given a number of lectures and hands-on training on power electronics, power system, drives, facts, HVDC, smart grid. He is a member in Board of Studies in various institutions. He is guiding a number of BTech and MTech PhD scholars. His area of interest are power electronics, renewable energy sources, drives, smart grid, etc. On behalf of everyone, I am very glad to invite you to this session, sir. I request you to go on with the session, sir. Thank you.
Thank you, ma'am. Let me share the screen first.
Yes, sir.
Is it visible?
Yes, sir, visible.
Yes, sir, visible.
Let me change the slides. Fine. Okay, now it's fine. It seems I'm audible, right, sir?
Yes, sir, audible, sir.
Okay, very good morning to all. And it's really a great pleasure to be part of this FDP. And first of all, let me thank the coordinator for inviting me for this one. And a special thank to ma'am for a wonderful introduction. So today what we are going to discuss for the next 1.5 hours is electric vehicle, G2B and B2G technologies. So that's what we're going to see today. But before going into the session, okay, just let me give a brief introduction about electric vehicle, why we need to go for electric vehicle, or why we want to go for such kind of technologies. As we all know, right, this is the area in which a lot of people are working on now. And you see, right, as far as India is concerned, by 2030, by around 30% of the vehicle running on the roads will be electric vehicle, right? And even it's same for the other countries too. So all the countries are just going for a transformation from IC engine-based vehicle to electric vehicle. And there's this huge scope for research in this one. If you see the scholars who are coming to work now, more than 50% of the scholars, irrespective either they are PhD or MTech, they are interested to work in electric vehicle. So this is the area in which we have a lot of scope for job and a lot of scope for research also. Okay. So today the outline of the presentation is we'll start with electric vehicle. Anyway, let me take about V2G and G2V. So, but before going to that, just to give you a brief introduction about electric vehicle. Then we'll see why we want to go for EV. What's the need to go for a huge transformation from IC engine-based vehicle to EV that we'll see here. Then we'll move on to what are the basic components of electric vehicle. Then what are the types? Then we have few components to explain. And all these things will cover grid to vehicle technology, because you're going to see two things. One is G2V, other one is V2G. So what we are seeing in the screen, with this we'll cover what is grid to vehicle technology. And we'll see one more basic thing called as demand side management. And with the basics of demand side management, we'll see what is V2G. So these are the things which you're going to see today. And actually, this is not a very small topic. It's very vast. It's like a sea. So, but let me try to give as much as information as possible within the limited time which I have. Okay. So we'll start with electric vehicle. As the name implies, it's a vehicle. It's an electric vehicle. So if you see the difference, there are a lot of difference between an IC engine-based vehicle and an EV. But if you see the basic difference, okay, if you see the drive, as far as EV is concerned, we have an electric machine, right? It can be a motor or generator. In general, we'll call it as a machine. The drive is a machine there. Whereas when you go for an IC engine-based vehicle, IC engine is a drive, right? That's a basic difference. One side you have an IC engine, other side you have an electrical machine. Then if you see the source, as far as electric vehicles are concerned, we'll be giving electrical input. Whereas when you go for an IC engine-based vehicle, you'll be giving the fossil fuel as an input. So this is a basic difference. Source is different and the drive is also different. Okay. But before going into such things, we need to know why we want to go for electric vehicle. Because we are going to have 5 days for this topic, right? But we need to know why we need. Because on one side, let me tell you the practical difficulties. This is a common when we have. Forget about the technical issues. Okay. See, when you want to go for a vehicle, for example, I want to buy a vehicle. Okay. Let me see. One side I have a IC engine-based vehicle. Another side, I have an option to go for EV. Two things are there. I have an option to go for IC engine. Another side, I have an option to go for EVs. Okay. So let me start with IC engine. Okay. You can see, right? You have n number of showrooms for IC engine. So option is wide open. Okay. But when you go for EV, the number of showrooms are very much limited. Okay. So that is one. Second one is the cost. If you know, for IC engine, the cost is less compared to EV. So the cost of electric vehicles are much higher than IC engine-based vehicles. So availability is an issue now, then the cost is also a problem now. Because as a normal person, we'll generally stick on to the lowest cost vehicle, right? Generally, few people may stick on to the safety and comfort, but the basic thing is the cost. Where you see the IC engine-based vehicle is less costly compared to electric vehicles. Okay, somehow I bought a vehicle, okay? And if you see IC engine-based vehicle, if I want to fill fuel, I can get everywhere, right? Once in 500 meters, I can see a fuel pump, either petrol or diesel or gas. Everything will be readily available. Whereas when you want to go for ICE EV, that is not the case. The number of charging stations are limited as of now. And depending upon the charging, if you're putting it in a home, level 1 charging, it takes 8 to 9 hours. Okay, see, one side you have a lot of fuel pumps where you can fill petrol within 2 to 3 minutes, but other side you have a very less charging infrastructure, which takes a lot of time, minimum 40 minutes for charging. Okay, if you go for a charging station. So filling fuel itself is not an easy thing. Okay, and after that, servicing, all such things are difficult now. So if you see from outside, IC engine has this much advantages, whereas EV has this much issues. Then why we need to go for EV? That's a big question, right? What is the need for electric vehicle? We have this much issues in electric vehicle, but still all manufacturers, if you start from Hyundai, Volkswagen, Nissan, Tata, everyone, they are moving into EVs now. Even all the countries, they are moving into EVs. If you see each and every state, in Assam, if you see, they are providing subsidy if you're buying an electric vehicle. When you're filing tax also, you can see the option inside. So why this transformation is required? Let's see that answer first. What's need to go for electric vehicle? Okay, we'll see the basic things first. The first one is, let me tell you 1 or 2 points, then I'll explain in detail. The first thing is the availability of fuel. As we know, all the IC engine-based vehicles are running in fossil fuel, either petrol or diesel or gas, whatever it is, they are fossil fuel. Okay, but the thing is that they are fossil fuel and their availability is very, very less. Anyway, let me skip all the things and I'll explain you. The second is well-to-wheel efficiency. If you see the efficiency of an IC engine-based vehicle, it's very, very less. I'll show you with some animations. So the efficiency of IC engine is very, very less compared to electric vehicle. The third one is pollution. You know, right? One of the biggest problems using fossil fuel is pollution. But whereas when you go for EV, there is no pollution. Right? The last one is capital cost and maintenance cost. As of now, the capital cost of EV is higher, whereas the running cost is very, very less. That's what if you see from outside, right? If you see from outside, the capital cost of EV is very high compared to IC engine, whereas the running and maintenance cost is less. But this is the case as of now. We have a lot of new technologies like battery swapping and all are coming. When that technique comes into picture, commercialized, then the cost of EVs will be coming down compared to IC engine. That I'll explain at the end, how the cost of EV is going to reduce. Okay, so as of now, the EV cost is higher, whereas running and maintenance cost is less. But if you see the advantage, whatever advantage you get it from EV, then this cost is not an issue. Fine. So let me tell you in detail. The first thing is that what are the advantages of electromobility? So first we have seen that the availability of fuel, right? So if you see whatever IC engine based vehicles we are having, they are running on fossil fuels. We know fossil fuels, they got deposited millions of years before, and nowadays we are utilizing it like petrol, diesel, and gas, all such things. They are not renewable energy sources, and one fine day they will come to end. If you see the graphs that are given, if you just go to Wiki, you can see the graph. They can see that by 2060 or 2070, the entire oil will get over. By 2100, you can see the coal will, everything will get over within a short period of time, because we are depleting them in a very, very faster rate. Just if you stand on a road and see for just 2 minutes how many vehicles are running, it's just only one road. If you see the entire state, entire country, if you see the whole world, all the vehicles are running in fossil fuel. Not only the vehicles which are running on the road, if you see the vehicles which are running in water, going in the air, all are running with fossil fuels, right? So if you see the amount of fossil fuel depleted in a day, it's very huge. And they are not renewable. So one fine day it will come to end. So one fine day we won't get petrol, we won't get diesel, there won't be any gas, right? That is the issue which is going to come. So we need to find an alternative for this. That is the first thing, availability of fuel. We need to find an alternate fuel. The second one is a problem with fossil fuels. even if the fossil fuel is available, there are a lot of issues with fossil fuel. The pollution is the biggest issue with fossil fuel. Okay, pollution is, it's not only with the vehicles. If you see the power generating stations like thermal generating stations, you can see a lot of pollution. Okay, so biggest problem of fossil fuel is pollution. First one is the availability, second one is the pollution. So pollution will lead to a lot of other things. Okay, the pollution will be there, then the gases will get accumulated in the atmosphere and they will come as acid rain, right? That is one thing. Then all these things will get accumulated in the atmosphere and they will it will result finally in the global warming, right? So all the issues are there with fossil fuel. Acid rain is there, global warming is there, and you can see there is a hole in the ozone layer also because of the usage of fossil fuels. So first thing is availability. Next is, even they are available also, they are resulting in all such issues. So somehow we need to come out of the usage of fossil fuel. That is very important. That's the first thing. Now let's see, EV itself has a lot of other advantages. Okay, this is simple. The first one is actually EVs run very quiet. If you have a two-wheeler, you can understand how much quiet it is. So, for example, I have an IC engine-based vehicle like a two-wheeler. I can understand whether the vehicle has started or not. But when I'm using an EV, right, it's very tough to understand because just there won't be not even a single noise when you drive the vehicle. Yeah, and we can understand the vehicle has started or not. Only just seeing the display can understand it has started because there won't be any noise from your vehicle. Okay, so they'll be much quiet compared to IC engine-based vehicle. But that is a basic advantage. There are a lot of other technical things too. Okay, and there won't be any harmful emissions or gases from the EVs. That you can understand, right? We have motors in our home, in fans, everywhere we have motors, right? The same technology is used in EV also. Only the type of motor is different. So there won't be any harmful emission from a motor, but whereas in for IC engine, there are a lot of emissions. So that is the biggest advantage. Okay, so any emission as far as electric vehicle is concerned. This I'll tell at the end. Then the motor which is there, it needs only very less maintenance. Whereas when you go for an IC engine based vehicle, it requires periodic maintenance, right? Once in 6 months, I need to go to a service station, I need to change the lubricant oil, everything A to Z I need to change or I need to maintain as far as an IC engine based vehicle is concerned. Periodic service is needed. If not, your vehicle will go off. But when you go for an electric vehicle, that is not the case because only there are three major parts. One is a machine, other one is a power converter, the first one is a source. Only three important things are there. So we don't want to go for much maintenance as far as EV is concerned. But IC engine needs periodic maintenance. So those costs and all come into picture. Then this is an important thing. As far as IC engine based vehicles are concerned, the efficiency of IC engine is from 35 to 40%. It's only for IC engine. When I'm connecting the transmission and all such things into picture, the efficiency will come approximately 25. This 35 to 40 specifically for the engine. When I'm connecting the transmission gear and all such things, it will come to 35 to 40. Sorry, it will come to 25. But for the machines which are used in an EV has an efficiency above 90%. You know, electric motor, they have highest efficiency. So the machines which are used in EV, they have efficiency above 90%. And when I'm connecting the transmission systems and other accessories, it may come up to 80. But just see where is 20 and where is 80. It's a huge difference in efficiency. So this is one of the biggest advantages of EV. They are highly efficient. See where 20% and where 80% is. Okay, so this is the biggest advantage of electric vehicle. The efficiency is higher. And then the drivetrain is simple. Because if I'm taking an IC engine, okay, IC engine based vehicle, for example, you just open the bonnet of your car and see, you can see n number of parts, like you can see clutch pad, muffler, carburetor, filters, air filter, A to Z components are there. But IC engine based vehicles have these much components. EVs have very, very less number of components. Or if you take our vehicle to a service station, after getting service, they'll give a very big bill. Then only you can see, oh, this many components were there in my vehicle. Those number of components are there in IC engine-based vehicle. But whereas you don't have that much components in an EV. So they're very compact and simple. Then this is one of the other biggest advantage we have with EV. Inherent regenerative braking is available inside EV. See, I think most of you are aware of what is regenerative braking, right? So what we have, if you have a machine, generally if you want to stop it, we simply remove the supply, it won't stop because of its inertia, it will rotate. So at that time, we'll be converting that motor into a generator, and we'll regenerate the kinetic energy into electrical energy, and we'll use it. So that is actually regenerative braking. As far as electric vehicle is concerned, you have a machine. That's why it's a machine. That means it can work as a motor or it can work as a generator. While running, it will work as a motor, and while braking, it will work as a generator. So when I want to brake the machine, when I want to brake the vehicle, okay, what it will do is that you have a lot of controllers and converters. So that motor will be converted into a generator, and whatever kinetic energy we have in the wheel is converted into electric energy, and it is stored in the battery. So you can brake it and you can store the energy. This is inherently available because the machine is a driving part that can work as a motor or generator. So that is inherently present. Whereas we don't have such an option inside your IC. That is not there. So here, this is inherently available. So whenever you want to brake a vehicle, you can store the charge in your battery. So that is another advantage. Then, and this is a third one. This is a very big advantage we have with EVs. Say for example, if I'm driving an IC engine-based vehicle, when I'm stopping in a signal, generally people will tell, right, if you're stopping a vehicle more than 1 minute, just turn off your ignition. But generally, most of the people won't do it, right? We'll just see the signal from red when it is going to yellow, when it is going to green, we'll be ready to move, right? Or if you have a counter, when it is counting as 10, then we'll put the gear. When it is coming to 5, we'll go for acceleration and we'll move off. We'll never try to switch off the ignition, right? Again, that is also a problem when you're switching off the ignition, right? Again, when it is coming to green, we need to stop, and people behind us will blow horn and all. So most of us will never turn off your vehicle in the signals, or whenever you want to stop anywhere. If you are stopping somewhere and I'm talking to someone, engine will be still running. Vehicle is idle, engine will be still running. But what is happening is that even though the vehicle is idle, engine is still running, it is consuming a lot of power. Whereas when you go for electric vehicle, the condition is totally different. You have a controller, it's a power converter, and a controller between your battery or source and the machine. Whenever the machine is idle, there is no power given to the machine. So when your electric vehicle, you are stopping your electric vehicle in a signal, there is no power given to the machine. Or if you want to talk to someone, if you're stopping somewhere and if you're talking to someone, the machine will be off. So no power will be given to the machine. That controller will make, control all such things. So in this case, right, whenever you're idle, there is no power given to the machine. This is called a standby losses. So like this, you can save a lot of power as far as EV is concerned. Whereas IC engine is concerned, if you're just stopping, if you're switching off, it's fine. But if you're still stopping the vehicle, even though the vehicle is idle, the engine is running, it will consume power. EV is not the case. EV is not the case. When you're idle, even though the vehicle is, when the vehicle is idle, the power won't be given to the machine. So that much power we can save with EVs. So these are a few advantages we have with electric vehicles. There are a lot of other advantages too. I will just give a few of them. Okay. Fine. These are some analogies which are taken from the journal papers. So these numerical values are approximate, just taken from papers. Okay. So assuming that I have an IC engine based vehicle, I'm driving in a city. Okay, I'm driving in a city. Assuming that the fuel tank 100% doesn't mean that it's full. 100% means I want to just calculate the efficiency. I'm giving 100% here. How much I'm getting in that side? That's the meaning. Okay. So I'm giving 100% input, and the engine is there. And you have seen that the engine loss, right? Efficiency is only around 35%. Remaining all will go as losses in the engine itself. So here engine loss is taken as 76. So 76 will go in the engine itself. Remaining 24 is there. And you have seen that as far as IC engine is concerned, whenever you are idle, the engine will consume power, right? That is taken as standby losses. That is approximately 8%. So only 16% will come in the driveline. And after that, you have transmission systems, which will take around 3%. So you can see only 13% is all approximate values. Real-time values will be much near to this one. So you can just see that 13% is coming to the wheel. I'm giving 100%, I'm getting only 13%. That means your petrol is around 100 rupees, but I'm getting only the value of 13 rupees in my wheel. Remaining 87 is going in the vehicle itself. See how much inefficient it is. The same vehicle, if I'm going a highway, obviously highway will go with a much better speed, so the losses will increase. And it is assumed that since you're driving in a highway, there is no signals and I'm not stopping anywhere. So standby loss is taken as 0%. Whatever it is, approximately 19 will come to the wheel. But in both the cases, you can see the efficiency of IC engine based vehicle is just less than 20, approximately 20. I'm giving 100 rupees, I'm getting only 20 rupees in my wheel. That's it. Okay, that's why EVs are highly efficient. But if you see EV, I'm having batteries. Again, I'm giving 100% input to the motor. And you have seen the efficiency of motor is always above 90%, right? So you're just taking 10% losses. It's about 90, around 90 now. And one thing we have seen is that the standby loss, as far as EV is concerned, there is no standby losses, right? Whenever the machine is idle, no power is given to the machine. So it's 90% is now coming to the drive line. Drive line is normal, losses will be there, and you can see around 86% is coming to the wheel. See, on one side you have an IC engine in which only efficiency is approximately 20. Here you have EV whose efficiency is approximately 86. You can see how much efficient it is. Okay, so if you see all these advantages together, you can understand why the huge transformation from IC engine based vehicle to EVs taking place. Okay, so these are the basic things. Now let's move on to the components of EVs. At the end, I'll tell you what is a grid vehicle. Okay, G2. As far as the EV is concerned, we have three main parts. One is a machine. Okay, we'll generally call it as a motor, or it can work as a generator. Then you have a battery. Battery is a generalized term. Now we have supercapacitors. We have fuel cell based electric vehicle also. Now we have green hydrogen based electric vehicles. A lot of new things are coming up. Okay, then you have a controller. Only three things are there. Okay, I'll just tell you what the types of all these things. We have a machine, we have a controller, and we have a source. Only three things. Okay, and if you see the classification in IC engine, we don't go for much classification, right? We have only diesel and petrol, right? That's all. Much it depends upon the variety of manufacturing processes. But EV have a lot of classifications. I'll just tell you the basic classification. There are a lot of classifications. I'll just tell you the basic classification. The first one is electric vehicle. Generally, we'll call it as a EV. B, battery electric vehicle. That's the first one. Then the next is a hybrid electric vehicle. Generally, it is HEV, HEV. And the last is a plug-in hybrid electric vehicle, which is a PHEVs. So these are the three. There is in between mild and a lot of other classification. I'll just tell you the basic. One is battery electric, next is hybrid electric, and the last one is plug-in hybrid electric. I'll just tell you what are these. Okay. This is a conventional vehicle. Okay, I have a wheels usual. I have a fuel tank where you can fill a petrol or diesel or anything, or you can go for gas also. Then you have an IC engine. Then the remaining transmission as usual. So if you want to go for battery electric vehicle, that's the only difference is at BEV. Instead of fuel, I have a battery. Instead of fuel, I have battery. Engine, I have electric machine. That's the difference. So IC engine has fuel. The same fuel is replaced by a battery pack here. There we have engine. It's replaced by a motor generator set. I mean, sorry, it's not a set. It's a machine. It can work as a motor generator. So that's a basic electric vehicle. You can see which are Nissan Leaf is a BEV. But here you can see there is no IC engine part. Only battery is. Only battery part is. Okay, so this is battery electric vehicle. But the problem with this battery electric vehicle is actually for small applications we can go for this one. But see, battery capacity is not that much. And the thing is that when you go for highway and all, this battery, you can't go for that much. Range is an issue. That is why you're going for a hybrid electric vehicle. As we know, the name hybrid, it's a mixture of two. A minimum two is needed. Right. So as far as BEV is concerned, charging, range, all such issues are there since it's running only on battery. Okay. So now we have something called as hybrid electric vehicle. It's a mixture of conventional as well as battery electric vehicle. We have hybrid electric vehicle, that is HEV, where you have this, let me tell you, conventional vehicle as one, battery as two. So now the battery part is here, 2 is there, and conventional part is also there. So this is actually hybrid. You have both battery part as well as IC engine part. So this is actually a hybrid electric vehicle. But as far as hybrid electric vehicle is concerned, the thing is that the charging of the battery will take place internally. That means from the engine or from the drive only, the battery is charged. That is the specialty of hybrid electric vehicle. But that is not that much efficient. So if you have a provision to charge the hybrid electric vehicle from outside, then if you have an option to plug in and charge it, then it is called as plug-in hybrid electric vehicle. So simple hybrid electric vehicle, there is no option to charge from outside, only from the engine and the transmission, wheel part it will charge. Whereas when you go for plugged-in electric vehicle, it is same as hybrid electric vehicle only, but the option to charge from outside is there. That is the difference between hybrid and plug-in hybrid. You can plug in and you can charge. But one question still is there, because we have seen the advantages of EV. First thing we have seen is that we need to eliminate the usage of fossil fuel. That is what we have seen. That is the biggest advantage of EV, that there is no fossil fuel and there is no emission. But here you see again, still the same fossil fuel part is coming into picture. Then what is the advantage of EVs? All advantages are gone now, right? Right? Because still the same IC engine and the same fossil petrol or diesel is coming into picture. And everyone is preferring PHEVs, right? Nowadays PHEV is preferred, right? Where you have battery as well as EV part, battery as well as IC engine part. Now the next question comes, what is the advantage of this? Because already again an IC engine is coming, again petrol or diesel is coming, then what is the advantage of this? Right? Then this EV doesn't have any sense, right? Because already fuels, a fossil fuel is inside now. So here comes a degree of hybridization. So what are example I'll tell, just it's just a example, right? These numericals don't take it as a real time value, just example. So when you go for a hybrid electric vehicle or PHEVs, you have two modes. One is that you can run in EV mode, other one you can run in hybrid, engine mode. Generally, when you're riding in cities, we'll go with EV mode. When you're riding in highways, you'll go with this fossil fuel mode, engine mode. So the degree will be approximately, initially it was approximately 25-75. It's not with highway and city. 25% of the running time will run with battery, because initially when it came into picture, the technology was not that much improved, right? The technology was limited. So the battery capacity was limited, controllers was very small, and all such things were there. So it was assumed that 25-75 was the ratio. That means 25% of the running time it is running on EV mode and 75 running on IC engine mode. Then with the improvement in technology, battery capacity, converter, machines and all, it may go up to 50-50, right? But still it's a huge field. A lot of research is going on, battery, because initially it is lithium ion. Now we have lithium sulfur batteries, sodium ion batteries, lots and lots of batteries are there. If you see lithium sulfur, it is claimed that once if you charge it, it can go up to 4,000 miles. Okay, so when you have this much technologies in the picture, and now we have a lot of power converters, fuel cell based things, and multi-port converter in which you can accommodate all the sources in a single converter. So when these techniques are there, now it would have reached 75 by 25. So 75% of the running time will be in EV mode, and only 25% it will run in electric mode. But still, it's not an ending, right? It's a research field. A lot of researchers are going on. You have a lot of improvement in battery management system, BMS, a lot of improvement in batteries, a lot of improvement in motors. Now you can see highly efficient motors like IPM CNRM is used in Tesla. It's a highly efficient motor. So when you have this much technology is coming up, one fine day, which is much near that, you can expect that it will be 100-0. That with all these technologies, you can assume that it's in a short period of time, the entire IC engine part will be eliminated and it will run only in EV mode. That is the expectation. Okay, so that's where the people are working on, right? So these are the classifications of EV. This is hybridization. You can just see the examples. There are a lot of examples. If you want to have pure electric vehicle BEV, Nissan Leaf. Nissan Leaf is a pure electric vehicle battery. We'll call Nissan Leaf as a iPhone on wheels. It's like, no, right? You have an iPhone, you can control everything in an iPhone, right? Same as that, it's like an iPhone which is kept in 4 wheels. You can control each and everything inside your vehicle, like you control your mobile. That's why there's a pet name for this one, iPhone on leaves. Okay, sorry, iPhone on wheels. And if you want to go for a hybrid electric vehicle, which doesn't have any option to charge from outside, you can have a Toyota Prius. Okay. But I don't know if it's existing or not, because no one will prefer hybrid. And all other cars like Volkswagen Golf, Chevrolet Bolt, Tesla, S3, S5, all Tata, all those things, and Nexon, all those things are hybrid electric vehicles. If they have option to charge from outside. So these are the vehicles which we have in the market. Now let's see the type of machines. We have seen three main things. One is a machine part, other one is a converter parts, and the source part. If you see the machine part, it doesn't mean that because we have seen a lot of machines. We have DC machine, we have AC machine, we have synchronous, we have special machines, a lot of things. But there is no specific machines which are used in EV. Doesn't mean that I'll tell that only DC machines are used. Or no one can tell that only induction machine is used. All machines are used in EV. It depends upon the type of the vehicle and type of the manufacturer. It depends on type of vehicle and type of manufacturer. In general, vehicles are using brushless DC motors. I'll tell you who are all using it. PMSM, permanent magnet synchronous motors are used in EVs. You have induction motors in EVs. You have permanent magnet switch reluctance motors are used in EVs. So these are the four, nice things that are used in EVs. If you see brushless, all small vehicles and low power vehicles, two-wheelers and three-wheelers, they'll go with brushless DC, irrespective of the manufacturer. It will go with brushless DC. Two e-rickshaws are there, then two-wheelers are there. Over the manufacturer, they'll go with brushless DC. Okay. Then permanent magnet synchronous motor, Volkswagen, all Volkswagen vehicles, Nissan, Chevrolet, all are going with permanent magnet synchronous motors. Induction motors, obviously, it was Tesla only. They were using Tesla. They were using induction motors initially, and now Tesla Model S3, they are using permanent magnet switch reluctance motor. So you can see that machines, only BLDC is different because these all low power vehicles are using BLDCs and high power vehicles are using this. It depends upon the manufacturer. And now Tesla is came up with a new motor. Again, Tesla Model S, they are using, I think, IP interior permanent magnet scenario. Yeah, this is another one which is used in Tesla, IPM scenario. Because induction motor has its own advantage, okay? A reluctance motor has its own advantage. So they are adding the advantage of induction motor and synchronous reluctance motor, because induction motor has different advantage. Reluctance motor has some other advantage. Someone can go with high speed. Someone can have a good starting torque. So they have mixed the concept of induction as well as reluctance motor, and now they came up with a new machine which is called as interior permanent magnet synchronous reluctance motor. That is IPM scenario. And they are using it in latest model. A lot of research is going on in this machine also now. So machines, it depends upon the manufacturer and type of vehicle. And batteries, obviously there's a primary source. And if you see power converters, we have, because without power electronics, nothing will work, because that is the one which is going to control the operation of the entire vehicle. It depends upon the type of machine we are using. If you're going for brushless DC motor, we have a type of converter. Whereas when you go for a permanent magnet synchronous motor PMSM, the converter is different. If you go for an induction motor, obviously mostly we'll go with the inverter, right, with V/F control. Permanent magnet switch reluctance motor, it's another converter. IPM scenario is a different type of converter, because initially it will run in induction, then it will go to sync reluctance. So each one will have different type of converters. Okay, so there is no specific converter. Doesn't mean that I can tell only DC converter is used. It depends upon the machine. DC machine, brushless have one type of converter, PMSM have one type, induction have other type. So converter depends upon the type of the machine which you are using. Okay, and the next is a battery. As of now, say whatever IC engine based vehicles, they are using lead acid batteries, whereas all EVs which are running on the road now, they are going mostly with lithium ion batteries. Okay, nickel hydride was there, but nowadays nothing is used. Okay, lead acid batteries are used in IC engine based vehicle, and nowadays lithium ion batteries are used. One of the advantage of lithium ion battery is high energy density, right? And you can discharge up to 20% of the battery capacity. That is advantageous. And nowadays, the cost of lithium, compared to the initial days, the cost of lithium ion is coming down, and the energy density is also coming up. So a lot of advancements are there in lithium ion. That's why most of them are preferring lithium ion. So it's not only EV. If you take a mobile or if you're taking a laptop, everywhere is lithium ion. But the thing which you need to keep in mind that lithium ion is not the future of EV. EV has different types of battery. When it comes to after 5 years or 10 years, it will be different, because nowadays everyone is using lithium ion is because of its advantage of high energy density, cost. It can be discharged up to a certain level, all such things, life. But one important thing which is hidden is that lithium is a non-renewable source. Lithium, because we need lithium, right? And cadmium, a lot of other things are there. Lithium is a non-renewable source, and this is not available in all the countries. In India also, we don't have it, since we will take it from other countries. So it is not available in all the countries, and it's a non-renewable source. See, now we can see approximately 1% of the vehicles are running on roads are EVs now. That itself has huge demand for battery. So after 10 or 15 years, when you have a number of EVs in your road, just think what will be the demand for the battery. Huge demand will be there for the battery. But the material which is used for the battery is lithium ion, which is a non-renewable source, which is available very, very less. So demand will be increasing, availability is very less, cost will increase, and all such issues will be happening. So now researchers are just going in a way to find some other option instead of lithium ion. A few manufacturers like Honda and all, they are going with the sodium ion. They're in the research for sodium ion batteries, because sodium is readily available, sodium ion batteries. And if you are working on electrostatic batteries, if you see Tesla, nowadays they are using lithium ion batteries. Now what the future is that the same lithium ion without anode. Actually, we know, right? We will be having anode and cathode for a battery. But Tesla has a patented technique where the battery will be without anode, the same lithium ion without anode. So cost and size will be reduced. It's patented, but commercially it's not there till now. Whereas there are a few manufacturers who are going for lithium sulfur battery. The specialty of lithium sulfur battery is that they are claiming that once you charge it, it goes up to 4,000 miles. 4,000 miles. So it's around more than 5,000 kilometers. You can, with one charge, you can travel from top to bottom of your country. But there are a lot of limitations there. That means the life cycle is less. So each and every technology has advantages and limitations. But still, we can expect that lithium ion battery will be there for a few years. After that, it will be different battery. Okay. So as of now, it is lithium ion. So these are the types of batteries used in EVs. Everyone is using lithium ion. You can see the batteries which is inside your EVs. You can see this is actually Chevrolet Volt. You can see battery. Okay. Now I have a battery, and how to charge it? That's a big question, right? And there are a few people are telling that it will take 8 hours. Few are telling that it will take 1 hour. Both are there. It depends upon the type of charging you're using. And if we see the classification of charging, there are a lot of types of charging. Level 1, level 2, level 3. Some may call it as AC and DC charging. I just put all those things together. We will just classify it into AC and DC charging. But whatever case it is, it's DC only, because you are going to charge a battery. It is DC only, right? But the way in which the conversion is taking place, we are classifying it into AC and DC charging. AC charging means it's an onboard charging. Onboard charging means the charger will be there inside your vehicle only. Charger is inside your vehicle itself. We'll have a wire connection, we'll plug it and we'll charge it. There is onboard charging. Okay. And the capacity is very less. Okay. Level 1 and level 2 are there. You can see that it takes around 8 hours for charging the vehicle if you go for level 1. If you're missing level 2, it takes around 3 to 8 hours. But these things mostly we'll do at your home. Level 1 and level 2, we'll try to do it in your home only. Okay. So with level 1, it takes around 8 hours. With level 2, it will take 3 to 8 hours. But this is not satisfactory, right? Because see, we are telling that IC engine is going, EV is going to replace IC engine. Where filling fuel will take just 2 to 3 minutes. Here you see 8 hours, 4 hours, and all those things is huge, right? So that is the next one, which is you can see this is an example of onboard charging. You can see beneath the seat, we are having the charge. Or I can show you clearly. Actually, this is actually a Chevrolet Volt. You can see this is a charger, which is in the back side. So here the charger is available inside your vehicle itself. This is onboard charging. But only problem is that this will take minimum 8 hours to charge your vehicle. You need to put at night 11 o'clock or 12 o'clock, go to sleep, morning it will be fully charged. Okay. This is onboard. Next is off-board. It's level 3 or DC charging. So here the thing is that it's off-board charging. Off-board charging in the sense charger is not inside your vehicle. Charger will be there in the charging stations only. It will be converted to AC to DC and it will be ready. We need to take our vehicle, go to the charging station and charge it. That is level 3 charging. Okay, and this is off-board charging. Okay. So here this charger we don't have in a vehicle because it's very huge. We won't use it in a home. These chargers will be available in charging stations only. We'll go there and we'll charge the vehicles. So whatever charging which is there in the charging station is level 3 charging or DC charging. Okay, and it's a fast charging. You can see in level 1 and level 2 it is 8 hours, 4 hours, but this is fast charge. Okay, and you can see, but the thing is that capacity is very high. It's around 350 kilowatt capacity. Okay, you can see a lot of conversions, a lot of converters, so it's huge size, cost is very high. So mostly this is not put it, you don't have this in your vehicle, this is in the charging station. So the advantage of this is it's fast charging, can go up to 30 to 40 minutes to go for 80% of charge. Okay, so that is advantages. It depends upon your capacity. If you're using, if you're using Nissan Leaf, you can have 40 kilowatt battery is there, 60 kilowatt battery is there. And if you're using 40 kilowatt battery, probably it may take 40 minutes. If you're using 60 kilowatt battery, it may take 45 minutes. Like this, it depends upon the capacity of the battery. But up to 80% only we can charge because it's a fast charging. So that is constant current charging, constant voltage on top. So it's 80%. So this is fast charging. The advantage of this is that anyone can charge this one, because if it is an onboard charger, only I can charge, right? Only my vehicle I can charge. No others can use it. But offport charging means anyone can go and charge it. It is very fast charging. Okay. But there are few disadvantages are also there, losses. Only thing is that only can charge up to 80%, because if you go deep into charging, you can see that there is called a constant voltage and constant current charging is there. Initially, it will be constant current, and after that, it will be constant voltage. Constant current is faster, constant voltage is less. I mean, it's very slow. Since it's a fast charging, it is only constant current and only up to 80% you can charge. But this is also fine. But there is another big problem. That means the life of the battery depends upon the number of charging and discharging cycles. Another one which is called a C rate, that is charging rate. So the rate in which you are charging the vehicle, that will decide the life of the battery. For each battery, they'll give the C rate. But this is a fast charging, so the charging rate is very high. So this will affect the life of your battery, because nowadays we have flash charges, right? In olden days we used to have normal charges, so it will take 3 to 4 hours to charge your mobile smartphones, but the life of battery was there. Nowadays we have flash charges, turbo charges and all, which can charge your smartphone batteries within 1 hour time, but just a trade-off is a life will go down. Okay, so the same thing here, it can charge it very faster and the C rate is very high. Another side, the life of the battery will come down. But still, everyone wants to charge at 45 minutes, right? No one wants to wait for 4 to 5 hours. Everyone wants to charge by 40 minutes. So obviously, everyone will be preferring level 3 charge. Okay. And okay, this is another important thing. Let me tell you. So what we are seeing till now, it is G2V technology. G2V means grid to vehicle. So the power is flowing from grid to vehicle. That is called as G2V technology, grid to vehicle technology. This is another important thing, battery swapping. See, whatever things, right? We have seen all such things here. But two things are still there. 40 minutes minimum charging it is taking, right? Initially, it was 8 hours. With level 2, it is 4 hours. But with level 3 also, it is 40 minutes. Okay, so the charging time is very high. We are telling that EV is going to replace that IC engine, but see where it is 2 minutes to fill the petrol or diesel. Or if no one is there, it can 2 to 3 minutes. If some queue is there, within 10 minutes, you can fill petrol or diesel and you can come out. That is enough. Or if you are standing as a third person, first person will take 2 minutes, second one will take 2 minutes, third one will go. Within 10 minutes, you can come. But EV is not the case. If it is taking 40 minutes, if you're the first person, it's 40 minutes. If you're the third person, first person 40, second person 40, then only your chance. Okay, so it will go with beyond 2 hours time, right? So that is a huge issue. Another thing is that, okay, somehow is there, but there are some critical vehicles, right? For example, when ambulance is coming, everyone will give way for ambulance. Okay, for charging also they have the priority, but still that is also battery. It will take 40 minutes time. Or if someone is driving a taxi, if he's taking a passenger, suddenly his battery is down, he is going to a charging station, they'll be telling to wait for 40 minutes. It's a loss, right? No one will want that, such kind of things, right? So that is the biggest problem we have. That is a charging time and range also. We don't have much charging stations in between. So one of the big important thing, or one of the biggest solution for all such issue is battery swapping. Okay. For example, in India, actually, as of now, Sun Mobility is giving. In Bangalore, I have seen it's there. Okay, Sun Mobility is giving this option. See, just example, if I'm taking, if you take an Ashok Leyland bus, if it's going to fill petrol or diesel, okay, petrol or diesel, it may take, surely it's a huge one, right? Huge fuel tank is there, 60 liter or something more than that is there. It may take surely 10 to 15 minutes. Minimum 10 minutes it will take either petrol or diesel if it wants to fill, right? Okay, that is it. Or if he's having a battery, it takes 40 minutes to charge it. But with battery swapping, you can see that within 2 hours, 2 minutes, 2.31 minutes, the battery can be changed. So battery swapping means swapping, you can understand, right? The meaning, just replace the old one and take a new one and come out. That is it. I'm going to a charging station, my battery is down, I'll go to a charging station, give that battery for charging, take another and come out. So you see the difference here. Same Ashok Leyland bus, it takes 10 to 15 minutes if you want to fill petrol or diesel. Or if you go for a normal charging, it takes 40 minutes. But with swapping, it takes only 2.5 minutes. That is the advantage of battery swapping. Go with a drained battery, give it for charging, take another battery and come out. Depending upon the charge available and all these things, you need to pay. That is a different case. This is the advantage of battery swapping. So here the charging time will be totally good. Range, probably nothing will come into picture. Okay, so this is the advantage of battery swapping. In India, we have Sun Mobility and PRG Autos. They have a tie-up, and all the PRG autos, they can go to a Sun Mobility station, they can keep the battery there, take another one and come out. So this will be going, it will be spreading out everywhere such that the problem with the charging will be going off. Okay, yeah, it's actually a tie with PRG is there. So that is it. So this battery swapping is one of the promising solution for most of the issues we have with EV charging. You can see rack will be there with charged batteries, and this charging batteries can just swap it. Even in two-wheelers, just give the battery, take another battery, fix it and come. Within 2 minutes you can do it, right? So that is the biggest advantage of battery swapping. It is in our country also now. But apart from all these things, there is a huge advantage for battery swapping. There is a very promising solution for EVs. So what you have seen is that the cost of EVs, if you see the cost of EVs, right, it's much higher than an IC engine-based vehicle with the same capacity. So, for example, if you take any electric vehicles, 50 to 60% of the cost of the EVs is for the battery. Any vehicle, 50 to 60% cost is for batteries only. If I'm taking a vehicle with the cost of 15 lakhs, right, the cost of battery will be around 7 to 8 lakhs. More than half will be going for the battery. 7 to 8 lakh is the cost for the battery. That is why it's very costly. Because remind is you have a machine, you have a power electronic converter and some other controllers. Their cost is very less. Only the cost of battery is making it costlier than an IC engine. So with battery swapping, what they're going to do is that, okay, actually what they will do is that the way EVs will come without battery. Electric vehicles will come without battery. So first time I need to take it into a battery swapping station, give some advance, and I need to fix the battery. Then I need to run it. Once it is down, again go and swap it. So in this case, as a owner of the vehicle, I am not owning any battery. The battery is owned by the utility only. So vehicle will come without battery. I have to go to a swapping station. I have to fix a battery, and it's not my battery. It is just for swapping it. Fix it, run it. When your battery is down, come to charge again. That means I won't own a battery. I'll own a vehicle. I won't own a battery. So if that happens, you can see the cost of electric vehicle will come down by 50%, because battery cost is around 8 lakhs out of 15 lakhs. Battery cost is around 8 lakhs. So if battery cost is gone, it's just 7 lakhs rupees for the vehicle, then plus or minus something, 8 lakhs or something. That's the cost of vehicle without battery. So this cost is much lesser than the IC engine cost now. That is what is going to come. But a lot of technical difficulties are there, but that will be eliminated. Okay, so that is another promising solution with battery swapping. In India, actually the Indian Oil Corporation, IOC, actually what they are doing is that all the IOCs, you can write, you can see all the fuel pumps of IOCs are there. In each fuel pump, I think around 82,000 or something. 80 or something around that. In each and every fuel pumps or IOC, they are going to fix a swapping and charging points. It doesn't mean that they are going to build a new infrastructure. They are not going to go for new infrastructure. In the existing fuel pumps itself, they are going to have a swapping and charging stations. So in the same fuel pumps, you can go for petrol, you can go for diesel, you can go for gas. If you can go for charging and you can go for swapping. As a number of EVs are coming up, the number of charging stations and swapping will increase and number of fuel pumps will reduce. And one fine day, the entire fuel pumps will go off and finally only EV charging and swapping will be left. So that is what it is going to happen. Now, let's start with the IOCs now, Indian Oil Corporation. Okay. You can see that the EV cost is just 40 to 60%. And when battery swapping happens, then it will come without battery, and the cost of batteries on the vehicle will be approximately same or much lesser than the cost of a IC engine-based vehicle. So what have we have seen? Okay, till now is BMS. I'll skip it because we are running out of time. Okay, what have we have seen till now is grid to vehicle. That means power is flowing from grid to vehicle. But one more question still exists. We are telling that EV, there is no emission, right? Fossil fuels are not used. Everything is fine. I'm plugging this, I'm having an EV, level 1 charging. I'm plugging it in the socket and I'm telling that EV is not emitting anything. It's like this. I have an EV. Initially, you can see there is a lot of emission from the EV. Then we are telling it's very dirty. It's emitting everywhere. Now, I have an IC engine. I have an IC engine. We have a lot of emissions. Okay, then we are telling it is emitting, it's dirty, everything. Now, instead of that, I have an EV here, right? There is no emission from the EV. I'm happy that there is no emission, but I'm plugging it and I'm charging that battery. See, as a country like in India, where 69% of the power generation is from thermal. If the power is coming from the thermal station, instead of emitting in the vehicle, I am emitting in the generating station itself, right? Anyway, both are same emission is there. In the previous case, I am emitting in the vehicle. In the second case, I am emitting a lot of emission is there in the generating station, right? So this is not clean and green. There is no use of having such an infrastructure, right? Because instead of emitting in the vehicle, the emission is there in the generating station itself. And if I want to consume 1 unit, then I need to generate at least 1.5 units there because transmission and distribution losses are there. So this is not an exact solution. So we won't get any advantage out of this. There is no emission. So what we need to go is that we need to go for more and more renewable energy sources as possible for charging the vehicle. Like what are new charging stations we are going to have? We need to have smart charging. Smart charging means we'll be having solar, wind, and a lot of other control technique where we'll be using mostly renewable energy sources. And very rare case we'll go for a grid, right? So when you are installing more and more renewable energy sources for charging the vehicle, then only we can get the exact advantage of EV. If not, if you're charging it from the grid where it is generated from thermal power station, instead of emitting in the vehicle, you are emitting in the generating station itself. That is not clean. Okay, it's like this. Practically there are a few vehicles which are running like this. Solar panel is there on the top, and you can see this is from China. You can see all vehicles are having panels in the top. They'll charge a little amount. Okay, so like this, we need to go for more and more renewable energy sources. Then only we can get all the advantages of electric vehicle. So what we have seen till now is a grid to vehicle. That means I'm having power in the grid. I'll be using a power converter where I will charge the battery. Then again, I'll use a power converter which will give power to the machine and it will run. That's a normal one. Now let's go on to the next. Another important thing as far as EV is concerned is V2G. That means vehicle to grid technology. There are a lot of technologies in EV where what we have seen till now is grid to vehicle. There is something called as V2V, vehicle to vehicle. That means you have power in your vehicle, you can transfer it to other vehicle also. That is V2V technology. We have V2B also. That means if you whatever power you have in a vehicle, you can transfer it into a building. That is V2B. You have V2G. That is whatever power you have, that can transfer to the grid also. So a lot of techniques are there in EVs. Okay, let's move on to the V2G technology, but this fuel cell, I'll just keep it. Okay, so there are a lot of things to know about V2G, but before going to V2G, let me take a just glance on demand side management, because explaining V2G with DSM is it's very simple. Okay, so we'll just see this one. I'll just show you a graph. So this is a typical load curve we have. Okay, in this load curve we can see that I think for a small amount of time. So this is a typical load. So you can see, right, load curve will have ups and downs. It's not a straight one, right? Sometimes it is increasing, sometimes it is going down, sometimes it may remain flat. For 24 hours, it will go like this, right? We can see that in the morning 12 to 6, okay, 12 to 6, the load is around approximately 2,800. Okay, fine. And in the afternoon time, you can see from from 6 to 5 o'clock, you can see it is around 3000. And you can see after this, it's a peak of around 4200. So you can see that it's not constant, it's varying with respect to time. Okay, so in the morning, assuming that I have 2800 timing, okay, that doesn't have anything, leave all those things. Let me come to the peak time. Okay, the peak time is 4200. I need to give this much power to the load, 4200. So I need to have a generating capacity more than 4200, because even though this 4200 is appearing only for a very short period of time, this 4200 is coming only for a very short period of time, I need to supply this power to the load. So I need to have a generating capacity for this only. Yeah. So what will happen is that this is a peak demand time, right? In case of peak demand time, what are the issues which are faced by grid is that the first one is that they need to have that much installed capacity. Sometimes the load is 2800, sometimes it is 3000, very short period of time it is 4200, but I need to have that much installed capacity to feed the load. That is one thing, install that much installed capacity I need. The second one, this is called as peak demand period, right? So as far as peak demand period is concerned, all the generators will be generating power. There are some generators which are less costly, and there are some generators whose cost of power generation is very high. That means there are few generators which can be used for a base load. There are a few generators which can be used as peak load, right? Their cost of power generation is very high. So during the peak load time, since all the generators are there in the picture, costly generators, very less cost generators, all those things are there in the picture, the cost of power generation is huge. During peak demand time, the cost of power generation is huge. But as far as country like India is concerned, we are not using TODs, time of the day tariff. We are giving flat tariff only, right? Every time, if you consume within 0 to 100, it is free. 100 to 200, it is 3 rupees. 200 to 300, it is 4 rupees. Like this only. It depends. It is not depending on the time, right? It is depending upon the slab only. But as far as grid is concerned, that is not the case. From morning, the load is very less. The cost of power generation is less. Here, the cost of power generation is a bit high, but during peak demand time, the cost of power generation is very high. But as far as the consumer is concerned, I'm not paying that cost. I'm paying a flat cost only. So the thing is that all generator has to be there in the picture. Cost of power generation is very high. Since all generators are running, right, it's very tough to control. Okay, that's fine. Next one. Since all generators are running, the emission is huge, right? Because all generators will be running, their emission is huge. The next one, if the utility is not able to give this much power to the load, they have to take power from outside, right? If they are not able to generate 4200 and give to the customers, they have to take power from outside. That power is very much costlier. Clear. So all those issues are there with peak demand time. Off peak and normal, it's fine. But during peak demand time, all the generators will be running. They'll be running at full capacity. Lot of emissions are there. Cost of power generation is very high. Lot of issues with control is there. And if they're not able to meet the demand, then they take pay from outside. Okay. In order to avoid all these things only, one of the best solutions for such kind of issue is going for demand side management, that is DSM. Okay, so there are a lot of strategies with demand side management. I'll just tell you one strategy. Okay, this one of the strategy with the demand side management is load shifting. There are a lot of strategies with demand side management, peak clipping, load shifting, energy conservation, energy building, a lot of things are there. But one of the very good thing for one of the very important solution for such kind of issues, load shifting, that is shifting the load. It's not cutting the load, it's just shifting the load. So for example, I mean, assume this purple color is actually the load. Okay, so what the utility want is that it encourages the customer to use more load during off-peak times and less load during peak times. That's simple definition. It encourages the customers to use more load during off-peak times and less load during peak times. Okay, so assuming that, well, let me tell you what is exactly happening in the grid and the customer. So this is off-peak time, right? So it encourages the customer to use more load during off-peak time. So the load has increased now. Yeah. And it encourages the customer to use less load during peak times. So since I used most of the loads here, I'll be having only less load now. So I'm using less load during peak times. So more load during off-peak times and less load during peak times. So now we can see the graph is a bit flat. This is what the utility wants. Okay. Another advantage is that you can see this much peak power has gone now. So it's much beneficial for the utility because they don't want to run all the generators now. They don't want to have that much installed capacity. They don't want to run all the generators. Cost of power generation is less. Emission is less. It's much stable and they don't want to buy power from outside. All these advantages are there with the utility. And what is the benefit for the customer? That is important because without any benefit, why I have to shift all the loads, right? So the benefit for the customer is that actually, if you see the tariff, in India, it's not there, only for HT customers there. The tariff is very less during off-peak hours and the tariff is much higher during peak hours. Since I'm using most of the load during off-peak hours, since the tariff is very less, I need to pay only very less. And during peak hours, I'm using very less load. So again, I need to pay only very less. So on a total, my bill will be reduced. Because initially I was using more load during peak hours and less load during off-peak hours. Now I am using more load during off-peak hours. So I need to pay only very less because off-peak hours is 1 or 2 rupees per unit. It's fine. Peak hour, it is 9 or 10 rupees per unit, right? There I am reducing the load. So I have to pay only very less. In this case, both utility as well as the customer will get benefited. It's actually a trade-off, win-win situation for both. So that's the advantage of demand side management. The benefit will be there for both utility as well as the customers. Okay. Now let's see how EV is coming into picture for demand side management. These are the basic things. Okay. So nothing is, we have seen 3 classifications of EVs, right? One is a battery electric vehicle. Another one is hybrid electric vehicle, and the last one is PHEV, plug-in hybrid electric vehicles, right? So if you see electric vehicles, till now we have seen them as a load. It will consume. If you take IC engine, they're simply the loads only, right? It will just fill petrol and it will go. That is it. And what we have seen till now is that electric vehicle as a load only. It will charge and it will run. That is all. But when you go for PHEVs, right? They are playing a very, very vital role as far as the grid is concerned. They can act as a load and they'll act as a source also. That is the beauty of PHEVs. When it comes to smart grid, you can see how much, what is the role of PHEV. There are a lot of roles for PHEVs when it comes to smart grid. Okay, so this can act as a source and it can act as a load depending upon the requirement. That much beauty is there. Okay, let me tell you what is B2G technology. Okay, see, assuming that, let me assume that there are, after a few years, there are a lot of EVs in a road, right? Assume that I have a mall. In that mall, you have a lot of parkings, right? You have seen parkings. And as per the study, as per a few papers, they are telling that 50% of the vehicles are always idle. That means, if you have n number of vehicles in a place, right, 100% of the vehicles will never run on the road. For example, if I take one person, he is going to office, morning he will drive for some time, then the car is parked in the office, evening only he'll be taking. So that much time the vehicle is idle there. If someone is having a car and two-wheeler, he will never travel in both, right? Either he will go in a two-wheeler or he'll go in a car. So one of the vehicle is idle. Another vehicle also, only travel he'll do, remaining during the office time is idle. Right. So if you see like this, right, even though you have n number of vehicles are running on the road, right, if you take any particular time, 50% of the vehicles will be idle. They'll be idle. Like, right, if I see a mall, okay, you have a huge car parking. Every time you go, it will be busy. You might have seen this case, right? Assuming that all are electric vehicles. See, each electric vehicle is having a huge battery. Minimum capacity of the battery is 40 kilowatt. It's an Nissan Leaf, small one, 40 kilowatt battery. I have 10 or 20 vehicles are there parked. If you had the capacity of all the batteries, it is equivalent to a generating station there. See, 40 kilowatt, right, into 10. 400 is there, right? 400 kilowatt capacity is there. This is for 10 vehicles. In a mall parking, you have hundreds of vehicles, right? So if you add the capacity of all the vehicles together, it's like a generating station, right? If it can supply power to the grid, then it is much beneficial. Okay, I'll tell you how it's happening. I'll just show you a graph. This is what. Okay, so assume that I have a mall, I have n number of electric vehicles there. Okay, electric vehicle, each and everything has a huge battery. Capacity is huge. Okay, if I add the capacity of all these things together, it is equivalent to have a solar plant or equivalent to have a generating station there. Okay, so one of the basic things of demand side management is that use more power during off-peak hours and use less power during peak hours. Fine. I have a lot of electric vehicles. All the electric vehicles we are charging during off-peak hours. Since we are charging during off-peak hours, I need to pay only very less. and the grid graph become flat. And during peak hours, okay, when the grid is facing trouble, that the demand is huge, they need to generate it fully, emission is more, cost is more, they are to buy power from outside. When all these issues are there, what these cars can do is that they can give the power which is stored in the battery back to the grid. It is not only one car. Any number of cars will be there. If all of them do the same thing, then the entire peak will be eliminated and the generation has to be only this much. This much power is taken care by the electric vehicle. Now, the power which has to be generated by the grid is like this only. And this power is taken care by the EVs. So this concept is called as vehicle to grid. This is one of the promising option as far as EV is concerned. Okay, it can act as a load during off-peak hours, and it can act as a source during peak hours and give power back to the grid. Okay, so this is called as V2G. A lot of technical issues are there that I'll tell you, right? So this is one of the promising solution which we can get it from electric vehicle. Okay, yeah. Okay, let me see. It's like this. Yeah. So, for example, when you go for I have a grid, forget smart grid. I have a grid, and when my vehicle is charging, charge will come through the converter to the grid. So that is grid to vehicle technology. And when I'm discharging this, it goes again through the converter to the grid. So this is V2G. So G2V means power will flow from the grid to the vehicle, and V2G means power will flow from the vehicle to the grid. Okay. There are a lot of technical issues out there which has to be addressed. There are a lot of people working in this one. The first one is about the converters. Because here we need bidirectional converters, because or double, because one time a V2G means power has to flow from the grid to the vehicle. So one side power flow is there, other means vehicle to the grid. Okay, then I need to go for another converter. In general, we'll go for bidirectional converters, right? Bidirectional converters means when grid to vehicle is there, power will flow from the grid to vehicle, and V2G technology means power will flow from the vehicle to the grid. So bidirectional converter is it's costly, and you see the losses also. Right, if you see the losses, it will be doubled now, because converter will have a lot of losses, right? Because the power semiconductor device. I'm 100% I am charging, so the converter it is coming. Some losses are there in the converter. It is stored in the battery. Again, it is given back to the grid. Again, some losses are there in the converter. So losses are prominent in this case. Converter cost is important because it's bidirectional now. Okay, all these things has to be taken care. And another thing is that the battery charge level. For example, I've charged a battery and giving my battery to V2G technology. They have drained all my battery, right? At night, and I got the car back. But if there is any emergency at night, I can't drive the car because it's drained. Or tomorrow morning, I need to go to my office. Night, I need to charge it. If it is not charging properly, again, it is a problem. So if I'm giving my car to V2G technology, if it is an emergency case, I can't drive my car because the entire power is drained now, right? That is a big anxiety for the drivers. But nowadays, they have fixed the limit that 25% of the capacity of the battery will always remain. That means whatever capacity you are giving, they will take only up to 25. 25 will remain in the battery always. So during any emergencies also, that anxiety problem is there, you can drive your vehicle. So the first problem is sorted out. Then second and third problem was very big. Now the control of the grid, you can just see the control, okay? Or before that, I'll tell you the life of the battery. We have seen already, the life of the battery depends upon the number of charging and discharging cycles and C rate. So already all EVs are going with highest C rate, right? So the life of the battery is coming down because most of the electric vehicle, except Hyundai Kona is giving 10 years warranty for the battery. Whereas all other vehicles, they are giving 8 years for the battery, okay? But since the C rate is very higher, the life of the battery will come down. That is one. Fine. I have a car. I'm charging it today. Okay, day 1, day 2, day 3. I'm charging it. One charging is over. I'm not taking part in V2G and all. Okay, so it is discharging. The next day also it will discharge. It will discharge. Third day again I'll charge it. 2 days I have driven somewhere, and third day I'll charge it. You can see now one charging, one discharging, and one charging. Only 3 cycles are there. Fine. Now, instead of this, I'm taking part in V2G technology. So morning, I'm charging fully. I'm going for somewhere and coming. Again, night, I'll give to grid, this discharge. They'll take part. Again, morning, I'll charge it. Again, I'll drive. Again, it will discharge. Next day morning, I have to charge it. Again, discharge. That means number of charging, it's not the exact value. Number of charging and discharging cycle is more in this case compared to the situation when I am not taking for V2G. Just initially, I have seen if you see the cost of the vehicles, 50% of the cost of the vehicle is for the battery. But when I am taking for in V2G technology, the life of the battery is coming down. Already with C rate, life is coming down. Now, since I am taking part in V2G technology, the life of the more charging and discharging cycle is there, so life of the battery is coming down. Since, for example, a car with 8 lakhs battery cost, no one wants to take such a risk, right? So there are also a lot of solutions for this one. And somewhere this utility may take care of the life of the battery or a replacement. Another thing is that there are a lot of smart charging techniques now which will control the charging current and which will maintain the life of the battery. So a lot of technologies are coming which will maintain the life of the battery. So that problem is also sorted out, life of the battery. Third is very important. Okay, it's like, say, we have studied about grid, right? Assume that I have a grid like this, conventional grid, right? Initially, we had conventional grid. So then power generation was there. Okay, the controllability was fine. Then renewable energy came into picture. Okay, they are supplying power to the grid. You know, renewable energy is highly volatile, right? Wind speed will change, solar radiation will change, right? The temperature will change, solar will be available only in the daytime, wind speed, all such things will change. So they are volatile in nature and dispatching them is very, very tough. So one side, when renewable is coming into the grid, you'll have a lot of issues because suddenly the renewable power will go off, suddenly renewable power will increase. So that much controlling is very tough to do inside in a conventional system, right? Because each generators, they have the ramp up, ramp down rates and all. So with the, this itself problem is there. Now, when it goes to smart grid, you have something called as a net metering, right? When you go for gross metering, it's fine. When you go for net metering, I'll generate power, I'll consume it, and the remaining power I'll give back to the grid. No one knows when power is coming from the customer and how much it will come from the customer, right? So with net metering, power will come to the grid. So now conventional, one side renewable, which is volatile, and one side net metering, which is unpredictable. Now the fourth one, from other side, you have now EVs. That is also giving. So it's like knocking your head in all directions. One direction renewable is giving power, one direction is net metering is giving power, one direction EV is giving power. How they'll control is very, very complex. Okay, so that is a research work which are going now. And one more thing is that this is unpredictable, right? See, there are 3 people, assuming that I have 3 people here. Everyone is charging to 100%. Okay. First person came out with 60%. Second person came out with 50. Third person is, he went out. He is there with 100%. So everyone wants to give the full capacity to the grid. Okay. So 25 has to remain, right? So this person, he can give 35% power to the grid. This person give 25% power to the grid. This person can give 75 to the grid. So when all these things are getting connected to the grid simultaneously, this 25% will come out first because he has given only 25. Next, this 35 will come out first. Then this will come out first. And some person, they don't want to give all the power. Some person can decide that it can give only 10% to the grid. So it is highly volatile. We don't know how many vehicles will come to the grid, right? How many vehicles will give power? How much percentage of power is remaining in each vehicle? How much percentage the vehicle want to give? Nothing is predictable. Yeah. So when you have such kind of generation in a picture, how to control the grid, it's very, very tough. So that is the next issue. But still a lot of research, because it's one of the promising solution and a lot of work is going in this area. Okay. Okay, so hope that you'll get a lot of good solutions for this one. So that is V2G. When you go for V2G, you'll be having bi-directional power will flow from grid to vehicle, and you can go for vehicle to grid. And these are the issues with grid. But in this 25, this is what I told, 25% is maintained. Okay. And another one is battery cost. Battery cost is also, and this is not there in our country as of now, but it's there in abroad. We have meters which will measure how much power I have given to the vehicle, how much I have taken, how much power the vehicle has given to the grid, how much power the grid I have took from the grid, and what is the difference between these two, how much I need to pay. All those there will be in the vehicle itself. You can see here. See this, it's in a car, it's a Nissan Leaf car. You can see energy imported to the car, how much I have taken, energy exported from the car, how much I have given back, and what is the difference? That's what I need to pay. with respect to the peak demand and all. That's fine. So a lot of advantages. So this is highly beneficial for the customer as well as the utility. Everything is controlled by our. You can see, energy imported is this much, energy exported is this much. All the things will be available in your vehicle itself. So this is another promising solution we have with EVs. And now we can see that in the car itself, we have a lot of options where it will restrict it to 25, and within that range, you can whatever power you want, you can give to the grid. Yeah, so a lot of options are there in this V2G technology, but still there are a lot of issues which has to be rectified, like the load management, how charging and discharging, how to maintain the life of the battery. All such things are there. So it's a promising area where a lot of work is going. Okay, and yeah, this is all you have seen. And before just winding up, let me tell you one more thing. Actually, as far as EV is concerned, it's not specific for a stream. That means, for example, when you take electric vehicle, it means that it's electric power electronics. It's not the case. Each and every stream of engineering has a lot of scope inside EV. For example, I'm interested in power electronics. Fine, you have a lot of scope inside EV because your battery charging is with a power converter, discharging is through a power converter, then your machine is driven with a power converter, regenerative braking is through a power converter, and all other accessories get power through power converters only. So power converter, you have a lot of options if you are interested in power electronics. If you are interested in power system, still, because your grid, your vehicle is charging from the grid only. How you are managing power in the grid? Because now when you go for n number of EVs, right, power management is very, very tough. And when you're giving power back to the grid, how to manage power? So if you are interested in power system, you have a lot of options. Or if you are interested in control, obviously, without control, nothing is going to work, right? Everything is controlled only. Charging is controlled. Everything is fully controlled. So without control, nothing is going to work here. So if you are interested in control, you have a lot of options there. Or else, I am interested in communication. See, everything is done through communication only. So you have CAN network inside, right? CAN bus is there inside your EV. When you're charging, communication is there. All the devices inside your EV will be communicating to each other to CAN. So if you're interested in communication, you have a lot of options inside. Or if I'm interested in computer, sure, a lot of optimizations are there. And one of the important problem with EV now is that the cyber security issues with EV. Initially, it was with computers, then it entered into the grid. Now it is entering into electric vehicle also. So cyber security issues are another important thing as far as EV is concerned. So if you're interested in that area, you can work on that. And you have a lot of cloud computing, a lot of other optimization things are there inside EV. So if you're interested in that area, you can work. An automobile, obviously, is a vehicle. You have a lot of options. Mechanical, it's everything is there. So this is not specific for any stream. Who are all interested to work in EV, you can work. And this is one of the area where you can do a lot of interdisciplinary works. You can join together and you can work. So I think that's it. Let me wind up the session. Now let me lead to the before going to the coordinator. So let me leave this to the coordinator for questions. If you have any queries, you can ask, or if you're not able to ask now, I'm just giving the contact details. You can mail me or you can put a message in my WhatsApp. Surely I'll try to help you out. Now it's back to the coordinator for the questions.
Thank you, sir. I request participants to post their queries.
So if they're not able to ask anything, they can put it in the chat also. I can read it and they can answer it.
Someone asked mail ID. It is already displayed. Sir has displayed his mail ID.
Yeah, better they can put it, if they want to do anything, they can put it in my Gmail rather than that NITS mail. Or I can put in a message in my WhatsApp also. I'll reply.
Feedback link is also shared. Please post your feedback. I think some of the participants can post their queries now.
Yeah, PPTs. I'll share the PPT. No issues on that.
So I would like to ask just a question, a single question regarding design of converter in a vehicle to grid technology.
Yeah, ma'am.
how to design the converter for a vehicle to grid technology. Means we should go only for bidirectional converter, or we can choose for research perspective either vehicle to grid or grid to vehicle. Any one concept we can take, or
That is fine, ma'am, because either you may work with vehicle to grid, or people are working separately in V2G and people are working separately in G2B also. So when you're working only in one concept, you can go for unidirectional converters itself. Because power flow is only one way, na?
yeah, yes, sir.
When you're concentrating on both, it's a practical case where we need to go for bidirectional conversion.
Okay.
Here, if you go for unidirectional, I need two converters. The cost is very high, very much higher in this one, this case. So I need to go for bidirectional. It depends upon either I'm taking V2G or G2B or both.
Okay, sir. Sir, regarding real-time simulation, for simulation we are using MATLAB alone, right? For real-time simulation, can we go with other softwares, sir?
Yeah, there are a few other
Apart from,
softwares.
OpenRT, can we go with any other software?
Yeah, even we are just trying to come out, because when you go for MATLAB, it's very tough to go with real time, because whatever is available only we'll be able to take it. So now we are trying to go with OpenRT as far as, but there are few softwares they are offering, but still we are not able to go with that now. But only MATLAB means it's very tough to go for practical implementations.
Yes, sir.
So we are trying with OpenRT now. We can do it. There is one question. Can you give some names of? I'll just let me find out, because Homer or something was there in separate. I need to find the exact name, because we are sticking mostly onto MATLAB. So it just come out. We are trying to find an option for that. So let me do one thing. The question is posted by, I think, Devi ma'am. You can just put a text to me. I'll just find the list of software which is available for EVs, and I'll share with the details.
Sir, actually, the problem is OpenRT, it is available in only very few institutions.
It's costly also. Yeah,
It's
that's
very
why.
costly. So something which can be apart from MATLAB, it will be helpful to all researchers and faculty as well.
Sure, ma'am. Just text me, give me a message. By today evening, I'll find an option and I'll let you know for that.
One more query. I think there are no more queries, sir. Kindly comment on hydrogen as a fuel for IC engine.
Yeah. Cameron hydro fuel cell for IC engine. Actually, now it's not for IC engine generally. How we are using is that we are using fuel cell for this one, EVs only. That is, instead of going for a battery, we are using fuel cells. And fuel cell need hydrogen. So there are a lot of advantages of going for this fuel cell based EVs, because the range is huge and the efficiency of the fuel cell is much higher than the efficiency of IC engine. So hope that soon what will happen. I think 1 year before the new hydrogen vehicle came into picture, that is Nitin Gadkari he has just inaugurated a new one with a hydrogen based fuel cell EV, and now that is going into picture. Instead of batteries, you are going to use fuel cells. And another thing is that hydrogen, there is an issue. So now what they are planning is they are going for green hydrogen. That means the hydrogen is generated from renewable energy sources. Okay. So that's which is going to come. But one more concept is that actually if you are using battery or if you are using fuel cell, the problem is that their transient response is very poor, because sudden acceleration and all, they can't help out. So nowadays you are having EVs along with supercapacitors. If you go for battery also, you'll have a supercapacitor which will help for sudden acceleration. If you are going for fuel cell also, you'll have a supercapacitor which will help you for sudden acceleration. So all these techniques are coming up. The future will be with fuel cells, it seems, because the capacity is huge, range is also huge, efficiency is also higher. Naveen sir, sorry, I'm not working with the vehicle to building, because we are working with V2G and G2B only. Okay, let me find the details for V2B also and let you know soon. Okay, because these two areas only we are working on. Okay, since I'm not aware of that, I'm not able to help you out. Just put me mail or put me text. I'll get the details and let you know regarding that vehicle to building.
Any more queries from the participants? not, we are going to wind up the session, sir.
Thank you. It was a very nice session with you all. Happy to meet you all. Thank you.
Thank you very much, sir. Today, regarding vehicle to grid and grid to vehicle technologies are very detailedly explained.
Amala ma'am,
Yes.
sorry to interrupt ma'am. Actually, somebody like Satya Pavan Kumar, maybe they wanted to put some query. They're trying actually.
Okay, they can ask, ma'am, but they have not posted anything in the
Yeah,
chat.
but yes, ma'am, they are actually unmuted themselves, but they are not asking. Sir, Pavan sir? Okay, ma'am. Carry on.
So, Srijit sir, thank you very much, sir, for the session. Vehicle to grid and grid to vehicle technologies are explained in detail. And we look forward for future sessions also, sir. Thank you very much, sir.
Thank you, ma'am. Happy day to all. We'll join again in future. Thank you.
Yes, sir.